Cool. Before we get started, I ate some bad nachos last night, so if my face looks a little angry sometimes, it's not you, it's my stomach is currently like fighting. I will try to have a good face on. Yeah. I'm generally have a pretty strong stomach, but anyways. Yeah, so let's get started. We're going to be talking about Zero Trust Security today, and we're going to be using the analogy of airports to explain this. A bit about me, I'm a developer advocate at a company called Pomerium. We're a really great tool to secure your internal apps and Kubernetes. It's a Zero Trust security solution. Excuse me. I'm from Montreal in Canada, and these are all the places you can find me online. So what are we going to cover? We're going to go over why Zero Trust matters. We're going to talk about the problem with perimeter-based security. And then we're going to go through that analogy of airport security as a Zero Trust security model. And then we're going to go over some of the core Zero Trust components. That's the policy engine. We're going to talk about micro-segmentation, context-defined access, and then we'll bring it all together with what's called the identity-aware proxy. It'll be a short demo. I added that today. I didn't have it the last 2 times I gave this talk, but I thought it'd be fun and also just live coding, so YOLO. We'll go over the benefits of legacy systems if you want to introduce Zero Trust security in your org. And then we'll just touch on Kubernetes very briefly. I was at KubeCon recently, and so when I gave this talk in London, it was fitting there, but I'll just talk about that a bit, and then we'll just talk about some key takeaways. A bit of background about me. I'm not a platform engineer. I'm not an SRE. I've been an application developer pretty much my entire career, doing a lot of .NET, C#, like first 2/3 of my career. I've led front end a bunch, done full stacky stuff. What is full stack anyways? But that's just set the stage where I'm coming from. I know there's probably a lot of platform and SRE experts in here and probably even some security experts. And the reason why I'm giving this talk is, one, I'm new to Pomerium. I started there in January. So this is helping me solidify my understanding of these concepts. And if you're new to Zero Trust, or even if you aren't, maybe it'll help solidify your understanding of it. Why does Zero Trust matter? There's a changing landscape. Microservices and cloud architecture expose a lot more access points now. APIs are accessible from pretty much anywhere. So this increases the attack surface. And basically, traditional perimeter security doesn't really fit the modern deployment model. Also, Zero Trust simplifies security decisions. You want to move it outside of application code. You want it to be consistent, and you ideally don't want to have any custom security code at the app level. Also, security is a shared responsibility, and we want to move security earlier into the development. I heard somebody talking, I think I was talking with Steven in the room where we're grabbing a coffee, and he's saying there's always tutorials or examples, and they don't even go into the real world of introducing security. Fitting, I think. That's me freestyling there, but I do think it's important to have tutorials and stuff where you actually show the stuff. It's not just, here you go. And also, developers implement auth patterns, not just security teams. So what is the problem with perimeter-based security? We'll start kickstarting our airport analogy here, and for any Foo Fighters fans, that's from the Learning to Fly video. But imagine going to the airport, you show your ID at security, they let you in, they don't check your bags or anything, and then once you're in the airport, you can literally do whatever you want. You could walk into any plane, any cockpit, other secure areas, go into the baggage area. It sounds a little weird, but that's really what perimeter-based security is. It's check once and then trust forever. Now, there's other things. There's remote work now, there's personal devices, cloud apps, there's all kinds of stuff. And this is starting to show the limitations of perimeter-based security. I'm sure a lot of people either have used a VPN or are still using a VPN. I remember working at Autodesk and connecting from home, and the assumption was you're in there and then you're trusted and you have access to whatever apps. And I think the other thing too is the reality nowadays is you should assume there's people in your network trying to do bad things, whether that's state actors, a disgruntled employee potentially, who knows. Yeah, so you can't really consider everything in there to be safe these days. And these are just some alarming statistics for shock value, but this is from an article from Bleeping Computer in, I think it was February, just like there's a bunch of VPNs getting hammered right now, about 2.8 million IP addresses. And the other thing with perimeter-based security is like literally once somebody gets in, your entire security posture collapses or potentially collapses. And what I was saying before, it creates a secure tunnel, but once you're in, everything's just assumed to be trusted. So if I wanted to go fly a plane, I'll just go walk into a Boeing 737 and say I'm the pilot. Yeah, there's things you can do for perimeter-based security. Like you can definitely add extra criteria at the beginning, like with multi-factor authentication. So I don't know, think of an airport if you were to go through security and they do a retina scan or something. But the reality is once you're in a perimeter-based security solutions network, you're just trusted. Even that extra layer is potentially helpful, but it's not, everything's assumed to be trusted once you're in there. Gonna take a sip of water here to help my stomach. And I made the mistake last time of using my water bottle, which has a wide mouth, and I basically all over me. So I grabbed one of these from the hotel. That way I look a little cooler drinking water while I'm giving a talk now. Cool. So let's talk about airport security in terms of zero trust. So in an airport, I'm assuming who's never been in an airport. I literally met one person about 2 months ago that had not been, which I was very surprised, but I'm going to assume everybody's flown at least once somewhere internationally or domestic. So you're all probably familiar with how things operate in an airport. When you get to the airport, there's that ID check, when you go through security, think of that like your initial authentication. There's a security screening. So you go through your bags, they get scanned. You can think of that as like device posture verification. And then there's also your boarding pass verification. And you can think of that as like resource specific authorization. Then there's gate agent checks. Think of that as like just-in-time validation before you're boarding the plane. And boarding the plane is like accessing a resource or an app. And then cockpit access, that's very hard to say. I think of that as like privileged functionality. So could be admin level stuff, but you also might need additional privileged access management to get in there. I think pilots literally use a physical key still to get into the cockpit. I'm not sure. I've never been a pilot, but if anybody has been a pilot, let me know. This will allow me to take a sip of water, but this is AI generated this for me. So this is just showing you what I've been talking about here. For anybody interested, that's actually a web application and it was built using bolt.new. Okay, we're going to talk about the catch me if you can vulnerability. Now, has anybody seen the film Catch Me If You Can? Yeah. So for those that might not have, it's a movie with Leonardo DiCaprio and Tom Hanks. And basically, Leonardo DiCaprio plays this person, Frank Abagnale. It's a true story. And basically, Frank Abagnale exploited trust-based systems throughout his career. His technique was literally get a uniform, pretend to be somebody, and people would just assume he's that person because he looked like that person. And this kind of ties into what I was talking about, perimeter-based security. They trust you, or you get somebody's credentials and you get in, and after that, they just assume, oh, he looks like a pilot, must be a pilot. And that's really the glaring issue with perimeter-based security. Yeah, so why it worked, what I mentioned there was no like contextual verification. Like they didn't say like, where's your pilot license? Where's the flight schedule? I don't see you. So no checks whatsoever and just no monitoring of suspicious behavior. I'm going to go ahead and read this verbatim because I think it's a really good quote from him. And this is also from a Google talk he gave. I can't remember the year, but that link will go to it and it's in the resources, but it's a really great talk. Even if you don't care about security, it's just a great story. And he said, all I saw was a uniform and said to myself, if I had a uniform on and I walked in a bank, it'd be a lot easier to cash a check than me just walking in as just some young kid. So the whole thing was about getting a uniform and doing that. So anyways, good movie too. But yeah, just wild that happened. So we're going to go over some of the core principles of zero trust security now. And we'll wrap this all up into what's called the identity-aware proxy. So the first thing you have is a policy engine. And if we think about airports, you're familiar with all these things, or at least in Canada, these are the requirements. So no liquids over 100 milliliters, if anybody wants to tell me what that is in ounces. But that's clear, specific restrictions. Your ID, whether that's your passport and your boarding pass, check that. Flight crew needs to have valid credentials, so it's like RBAC. And here's some things that can happen. Gate changes is like resource relocation, so policies get updated. There could be a maintenance window. I know my bank typically goes down on the weekend on, I don't know, after 10 p.m., which I find it odd that a bank goes down for maintenance, but anyways, can happen. Then there's like flight status and service status in the context of the policy engine. And that's like real-time conditions that influence decisions. And this is literally what happened to me just like a month ago. I gave a talk at All Things Open AI. And this is the first time that I actually had a flight canceled, and then the gate changed when I got a new flight, and then I got a new time. And anyways, it's very stressful because I was sleeping when I woke up. I had received an email an hour before I got up that said my flight was an hour early. So I literally woke up, I had all my stuff packed, called the Uber, raced to the airport. I literally got through security in 10 minutes. And then I was just very lucky that the gate was literally right in front of the security, but otherwise I would have missed it. And I don't know, it's the first time this happened to me. I'm flying a little more now. Anyways, so let's talk about micro-segmentation. And basically think of this as like security zones for your digital assets or resources. So you can think of like the public concourse in an airport, public-facing surfaces, kind of like the open internet. Boarding areas could be like departments or team resources. Individual planes are resources or applications. And like I was saying before, like the cockpit could be something like administrative functions or something that requires some more privileged access management. And the thing with microsegmentation is, like I was talking about before with perimeter-based security, once you're in and you have access to the whole network to potentially do nefarious things. It's also fun to say nefarious. I sound sneaky now. But with microsegmentation, it's literally like this specific resource has this certain policy, and you can't go left, you can't go east or west in there. It's like you can only go to that resource if you have access to it, and it won't affect the rest. And that's like a huge difference. And I know there's next generation VPNs that do claim to have microsegmentation, but from what I've read and learned so far in my 3 months in the space is for those next gen VPNs, there is segmentation, but it's really more network based. So it's not like resource X specifically, it's maybe a sub network within there. And I'm mentioning this too because this is in general, but like sometimes people claim to be certain things, and we see this happen in software a lot. So it's like when you see, I would say if you heard some of perimeter-based security solutions saying there's zero trust, they're not really. And I'm not saying that to bash them, it's just factual. There could be zero trust-like concepts in it, but it's not truly zero trust. Yeah, and like I was saying, so you can, with this microsegmentation, each resource, you can be super granular with what the access is, the policies, specific devices, like the list goes on what you could do in terms of a policy. But I think the reality too, though, is like everything gets hacked at some point, but all these things put in place make it super difficult for people to do this. Just gonna do a time check. Cool. Yeah, so I was mentioning about the microsegmentation with VPNs. I got a bit ahead of myself there. And so let's talk about context-defined access now. So we have the policies, we have the resources, which are micro-segmented. So, you know, when you determine what you want to access, it's not just like you logged in through your identity provider and you say who you are. There's roles as well, but there could be other third-party data. Like for example, if you use PagerDuty or something, there could be like an on-call schedule, and that comes into the policy management. And that can introduce some interesting things like time-based access because you're just on support for the weekend. And also the location matters too. If we come to here, if someone with a pilot's ID trying to enter the cockpit at off hours at a gate where there isn't a plane scheduled is, as SpongeBob is alluding to here, a little sus. And in the context of like real world of software, think of a senior, it doesn't have to be a senior engineer, I don't know why I put that, but someone accessing the prod database at 3 a.m. from an unrecognized device in a foreign country, even though they were able to log in, policies will help mitigate stuff like that. Who knows, maybe you have a policy that says, yeah, it's okay to log in Thailand from some weird iPad. Cool. So we're going to bring this all together now. So there's this concept of something called an identity-aware proxy, and it's a security service that sits at your network edge. And the reason for that is because you want to have as little latency as possible between the policies and everything getting checked there and your internal network. So there is technically some latency, but I would say it's like negligible. And so it acts as a central access point for all your apps, and it operates at the layer 7 in the network stack. So you have full control of what's going on, like where they're going to, cookies, JOTs, whatever, it's all there. And basically, say I want to go somewhere, I'm going to have like my policies. You obviously have to be logged in, and then you put all that together with what are the resources you're trying to access, and that becomes your whole context-defined access. And this is what it looks like. This is a generic one, and this is what Primarum looks like where I work, but this is, in essence, what an IAP looks like. So essentially you have your identity provider, and it can be whatever you want. Like I put some common ones there, but you could have your own, Azure, whatever is there. So the first thing you're going to do is you could be, and the thing about perimeter-based security, like I was saying before, you don't even have to be on the network. This is just anybody trying to access these internal apps. So basically somebody from the internet, wherever they are, they want to access some protected service. So they hit this particular route that will eventually proxy to the actual internal app. But first things are, okay, you're not logged in, let me log you in. Okay, you were successful there, cool, let's check the policies for that particular resource. Okay, everything checks out, okay, you can go ahead. And that's the whole flow, but it's not just a one-time thing. This literally happens every time, like literally every request. And this is why it's important that you have this software at the network edge, because there are cloud offerings and stuff too, but that can introduce latency. So yeah, just doing a time check. Cool. All right, I might have to skip the demo, but that's okay. Yeah, and so the key principle here really is never trust and always verify. So I'll just go through some things again from like the airport analogy, but the public internet is like just get into the airport. Your IAP, the identity-aware proxy, is literally all the security that happens in the airport. And then the policy evaluations are like, gate checks, security checkpoints, check your boarding pass. And like when you've been to the airport, you get to the security initially, and then you have your passport. They want to see your boarding pass. Maybe you go somewhere else, but once you get to your gate, you got to show your boarding pass again. Sometimes even on the plane they ask, because some people try to sneak into, I think, first class. I haven't done that, but maybe I can Frank Abagnale that one day. And again, just to iterate, like applications or resources are like individual planes at the airport. Admin privileged access is like accessing the cockpit with other additional requirements like privileged access management. And the main thing, continuously verify. I am going to skip the demo because we're already at 4:43 here. But in essence, all I was going to show is basically a policy applied to a route, and then you can see it being applied where you can either access it or not. Happy to show that after if people want to see that, but we'll skip that for now. And I'm just going to, as we're closing up here, talk about the benefits for legacy apps. Basically, I think every company probably has some legacy apps, or maybe there's acquisitions and mergers, you get old tech and stuff. And it might not be uniform security when you get these things. What you can do with Zero Trust security, you can literally throw the IAP in front of all these things, and you will automatically get that consistent security posture that I've been talking about. And yes, there is a migration path for those legacy apps, because say something had, I don't know, like just basic auth, you could still go through the IAP and it would take you to that legacy app, but you would still have to do that basic auth once you get to it. You could eventually migrate to just say my identity that's coming from the IAP can be handled in application code. So like, honestly, if you're managing infra, this seems like a no-brainer just to throw an IAP in front of legacy apps. I won't go through all the points here, but I'll let you all take a peek there because we've got 3 minutes here. I'm just going to wrap up quickly with an implementation path. So you basically want to do an assessment phase, identify your critical apps, document the current access patterns, do an inventory of security controls. And I'll mention this a few times, but Zero Trust can coexist with perimeter-based security, because the reality is probably a lot of companies can't get rid of their VPNs right now, or maybe they don't even want to. But whatever you put behind Zero Trust security will definitely have way better security posture. You could do a pilot implementation. This is all hypothetical, but these are just ideas. Start with a single app, implement some basic identity verification, test with a smaller group. Again, layer 0 trust alongside existing security. And then expand. You could add more context-based policies, super complex, maybe tie in your PagerDuty or something, add device posture checks. You can actually link that up to a company device database, for example. And if you can, you could begin phasing out perimeter-based security. Again, you don't have to. They can coexist. And then the maturity phase is just keep doing that, rinse, repeat kind of stuff. And I'll just mention Zero Trust with Kubernetes really quickly. Basically, you can secure your API, the Kubernetes API. You could also have an ingress controller that basically leverage everything I've been talking about. You can use the IAP in front of your Kubernetes API so that you can literally have all that same security posture, and you can gate what people do with the Kubernetes API. I'm also not a Kubernetes expert. I'm very green. If I'm talking out of my butt, please tell me. And yeah, you just get this consistent security posture. And just key takeaways. Hopefully, after talking about airports and Frank Abagnale's Zero Trust is a little more intuitive now. Remember, it's about context, not where you are on the network. Always be verifying. If you do consider this, you can do this incrementally to adopt it, and you can just evolve your security posture. And there's some resources and slide deck if anybody's interested. And yeah, that's pretty much it. Thanks, everybody. My stomach feels slightly better. I don't know. I guess talking helped.
Any questions?
Oh, yeah. Cool. So actually, it's going to take you to Rick Astley.
Do you ever have people say, no, we haven't seen the movie, and then you have to do a different presentation?
Yeah, at that point, I reenact it, but it extends the talk to about an hour and a half more, but it's fun. Gets intense, though. It's hard playing multiple characters.
All right, going once, going twice.
Go for it.
Do you know any, like with pfSense, which is a commercial router that's running on BSD? I wasn't sure if there was another tool that could basically interop with that as far as the IAP thing. Wasn't sure about that.
You mean
there was any open source
installing the IAP on the router, you mean?
Yeah, if there was anything like, or I once worked at Cisco and they were doing IPsec, and I wasn't sure if that basically enters into it or not at the networking level.
The thing is, you immediately can't have Zero Trust if you're at like layer 3 or layer 4, because it's at that point, like I know there's some next gen VPNs that decrypt packets to try and figure out what came initially at the layer 7, where it sits. So I don't know if that's answering your question, but it's
because IPsec was basically you were brought on the network that basically was like it was complicated.
Okay.
But basically, you basically were in a special network. You had to basically authenticate, and only certain MAC addresses were basically allowed. So basically the authentication was actually at the MAC address level.
Yeah.
So
but,
I mean,
but at that point, even though that's more complicated, you're still given access to the whole network. You know?
It was all specially. You were in a different VLAN and all sorts of whack stuff.
Yeah, and yeah.
Magic.
Yeah.
Thank you.